The daily water consumption of households in a town is assumed to follow a normal distribution with a mean of 120 litres and a standard deviation of 15 litres. We're told that a city official claims that the average daily water consumption per household has decreased. So that's our keyword for this question, decreased. A random sample of 40 households was surveyed. And the sample mean daily water consumption was found to be 115 litres. And then at the 5% significance level, we have to test this claim. So our null hypothesis is that our mean is 120 litres. Actually, I'll just write 120. And our alternative hypothesis is that this has reduced, or has decreased. So our mean is less than 120 litres. So it says that it's normally distributed, so we can write our daily water consumption as x. That's normally distributed as 120 litres and a variance of 15 squared. So we can distribute the sample mean. It's going to have the same mean, and its standard and its variance is just going to be 15 squared divided by our sample size, which is 40. There's two main ways we can go about doing this. One is that we use the Z statistic, and the other is that we directly find the probability of it happening through our calculators. Okay, so I think we'll do the Z statistic for this video. So remember the equation, Z equals our value minus our mean divided by our standard deviation. And in the case of this sample mean distribution, our value that we're looking to be less than is 115, and our mean is 120. And our standard deviation is going to be the root of 15 squared over 40. And that equals minus 2.108. We'll do 3 decimal places. So we need to find our critical value for this test. And the way we do that is if we go to over here, we look, it tells us that we're at the 5% significance level. That is the, so if we draw our standard normal distribution over here, just like a rough sketch, it'll be like, because this is on the left tail, this is a one tail test, this will be the 5% that we're looking at. So anything this direction, so we're looking at this Z value, whatever value of Z lies here. If minus 2.1808, whatever we had, is on this side, then our results are statistically significant, and then we'll reject our null hypothesis. So let's go on our calculator. You can go to the inverse normal function, and the area that we're looking at, we're going to put in is 0.05, standard deviation of 1 and a mean of 0. And that gives us a Z value of minus 1.645. So that is over here. And from that you can see that the minus 2.108, it lies on the left of that, and therefore our result is statistically significant. And we'll write that formally, like, write it over here. What was that? Minus 2.108 is less than minus 1.645. Therefore, we reject our null hypothesis. If you remember, our null hypothesis was that our mean is 120. But over here, we reject the null hypothesis, and there is sufficient evidence to suggest that the daily water consumption has decreased, per household has decreased. Okay, so that'll be it for this video. Thank you for watching. Let me know if you have any questions.